So you open up Claude or ChatGPT or Gemini, you type something in, and bam, a brilliantly structured answer just appears in seconds. It honestly feels like magic, doesn't it? Well, behind that one single response is actually one of the most expensive, complex, and frankly, scientifically fascinating processes humans have ever built. Welcome to the explainer that shatters that illusion of AI as magic. We are taking you on a full factory tour today, from a massive glowing server farm all the way to that clean little chat window you use every single day. We're going inside the machine to see exactly how these models are actually born. All right, let's quickly look at our roadmap for this explainer. We'll start off with the 2 phases of AI. Then we'll dive into pre-training, building the brain, followed by post-training, shaping the personality. After that, we'll explore teaching AI through human feedback, constitutional AI, and self-correction, and finally, why model training actually matters for you.
Okay, section 1, the 2 phases of AI. Let's get right into it.
So, building a frontier AI model essentially happens in 2 completely distinct steps. There's a great quote from Meta AI's Llama research paper that really hits the nail on the head here. It points out that almost all knowledge is learned during the initial pre-training phase, and only limited instruction tuning is needed afterward to actually shape the output. So basically, pre-training gives the AI its raw brain, while post-training gives it its personality and values.
To really visualize this, think of the electric blue pre-training phase as an ultra-powerful sponge. It's just absorbing all of the world's knowledge. It's totally raw and unfiltered. Then you have the teal post-training phase. This phase takes all that raw chaos and aligns it into the helpful, safe, and conversational assistant that you're actually used to interacting with.
Moving right along to section 2, pre-training, building the brain. Pre-training essentially relies on a relentless, massive game of predicting the next word billions and billions of times over. And the sheer scale of this game, it is literally mind-bending. 13 trillion. Get this, GPT-4 processed an estimated 13 trillion tokens. That's the equivalent of roughly 10 trillion words. To put that into perspective for you, the average human reads about 1 million words in their entire lifetime. So the AI is doing the equivalent of 10 million human lifetimes of reading just to figure out the underlying patterns of language and logic. Crazy, right? But, where do you even find 10 trillion words? Well, everywhere. This immense scale of data is mostly English text, scraped from all across the web. We're talking Wikipedia, books, scientific journals, Reddit threads, the whole shebang. But crucially, and Meta's Llama 2 data breakdown perfectly illustrates this, that text is deliberately mixed with about 10% programming languages, along with other natural languages. That code is actually what helps the model develop structural reasoning skills. Now, obviously, you are not processing 10 million human lifetimes of reading on your laptop. Handling all this data required running thousands of powerful NVIDIA GPUs, like the A100s, 24 hours a day for over 90 days straight. It is a massive, heat-generating, incredibly power-hungry physical undertaking. And, as you might guess, all that heavy-duty hardware comes with some absolutely staggering price tags. According to the Stanford 2025 AI Index, this sheer computing power costs hundreds of millions of dollars. Just the compute for GPT-4 alone was somewhere between $78 and $100 million. Meta's Llama 3.1 hit $170 million, and Google's Gemini Ultra, that reached an estimated $191 million, which perfectly explains why only a handful of organizations on the entire planet can actually pull this off. Giants like Google DeepMind and Meta AI are spending these staggering amounts of money and building insane infrastructure just to create these base models. But here's the catch. The result is highly capable, yes, but it's completely raw and unfiltered. If you ask a raw-based model a question, it might literally just write another question right back at you. It has a brilliant brain, for sure, but absolutely no idea how to actually be an assistant. Which brings us to section 3, post-training, shaping the personality. Because that raw-based model is just a chaotic text predictor, we absolutely have to move into the crucial phase of taming it. And the very first step here is supervised fine-tuning, or SFT. SFT uses thousands of high-quality human-written examples of perfect conversations. Now, this doesn't add new world knowledge. Instead, it teaches the model exactly how it should structure its responses to follow your instructions. It's basically learning the format of being a helpful conversational partner.
Next up, section 4, teaching AI through human feedback.
Okay, so format is great, but it isn't enough on its own. Next, we add a layer of behavioral optimization. And this is what fundamentally changed the entire AI landscape and turned these tools into a global phenomenon. By 2025, 70% of enterprise deployments, including the ones from OpenAI, relied on a technique called reinforcement learning from human feedback, or RLHF. This was the absolute key to ensuring models were both safe to use and genuinely helpful. Here's how that actually functions in practice through a three-step pipeline. First, the model generates multiple different responses to a prompt. Second, human raters compare those options and pick the best one. And finally, the system uses millions of those human preference signals to train a reward model. That reward model then turns around and teaches the main AI exactly what kinds of answers we humans actually prefer. But as you can imagine, training 3 separate models for RLHF is really expensive and incredibly slow. So the science evolved super rapidly. We went from the classic setup of RLHF in 2022 to direct preference optimization, or DPO, in 2023, and then on to advanced verifiable reasoning techniques like GRPO and RLVR in 2024 and 2025. Those newer techniques actually force the AI to mathematically check its own logic. Techniques like direct preference optimization are just incredible because they are mathematically proven to be far more efficient. You literally just skip the separate reward model entirely. This kind of efficiency is exactly what's allowing developers in the open ecosystem, like the folks over on Hugging Face, to align really powerful models at a fraction of the original cost. All right, Section 5, Constitutional AI and Self-Correction. Now we're going to look at a totally unique alignment strategy. This one bypasses the bottleneck of those expensive human raters entirely and replaces them with an AI-driven rulebook. Anthropic, they're the team behind Claude, actually pioneered this. It's called constitutional AI. In this system, the model uses a written set of principles, literally a constitution, to self-critique and revise any harmful outputs. So it evaluates its own responses against these rules, relying on AI feedback rather than human opinions to scale up safety way faster and far more consistently. And the research in this space just continues to accelerate. Excitingly, some fresh research from May 2026 reveals that directly training models on these constitutional documents, and get this, even on fictional stories of admirable AI behavior, drastically improves their safety. And that holds true even in unpredictable situations that the model has literally never seen before. So, looking at the complete picture side by side really helps clarify things. Pre-training gives the knowledge, post-training gives the behavior. A great analogy is that pre-training is like an incredibly expensive, years-long university education, while post-training is that rapid, absolutely vital, on-the-job training that actually turns a new graduate into a functioning professional. Finally, Section 6, Why Model Training Matters. So why should you even care about this massive technical pipeline? Well, understanding this is exactly what turns you from a casual user into an empowered, critical thinker who can really get the most out of these platforms. Because when you understand the training, you understand the output. When a model refuses a harmful request, you know that's constitutional AI at work. Knowing how SFT and human feedback function allows you to structure your prompts in a way that the model's trained personality is actively looking to reward. You can prompt better, and you can evaluate different AI tools far more critically, knowing that a stellar post-training process can actually make a smaller model vastly superior to a poorly aligned larger one. Now that you know exactly how an AI transforms from a chaotic text predictor into your trusted assistant, I would love to know which phase of this explainer completely changed your perspective. Was it the staggering cost and sheer scale of pre-training, or maybe the ingenious self-correction of constitutional AI? Think about it, and let that shape how you interact with AI today. Keep learning, keep exploring, and I will see you in the next explainer.